Hello and welcome to yet another South Korean college Scholastic Ability Test problem, which South Korean high school seniors need to solve in order to apply for the college. Today's problem is, for functions fx and gx that are twice differentiable on the set of real numbers, let integral of f prime x g1 minus x minus g prime x f1 minus x from 0 to 1 equals k. Then which of the following are correct? A. Now we have integral of fx g prime 1 minus x minus gx f prime 1 minus x from 0 to 1, and this equals minus k. And B. If f0 equals f1 and g0 equals g1, then k equals 0. And C. If fx equals ln 1 plus x to the power of 4 and gx equals sine pi x, then k equals 0. So we must determine whether these statements are true or false. So obviously, we need to check these statements one by one, starting from statement A. Here, this is the definition of k which is given in the problem. And let's compare the integrand part between these two. Comparing the positions of x and 1 minus x in these functions and their derivatives, you can easily notice that we need to use the integration by substitution with 1 minus x as t. This gives x equals 1 minus t, and thus dx equals minus dt. Then the left-hand side of this integral can be written as integral of f1 minus t g prime t minus g1 minus t f prime t negative 1 dt, and the interval of integration becomes from 1 to 0. Here, notice that by eliminating this negative 1, we can convert the interval back to from 0 to 1. Also, let us take out minus sign to the front. Then we must write this part first, hence f prime t g1 minus t, and then this part, hence minus g prime t f1 minus t. And if you compare with this definition of k, you know that this part is exactly k. Therefore, due to this minus sign, this equals minus k. Therefore, statement A is true. Next, let us determine whether statement B is true or not. Here, we have to determine whether k is equal to 0 or not. So naturally, we need to start from the definition of k given in the problem. First, let us split this into two integrals by writing integral f prime x g1 minus x dx minus integral g prime x f1 minus x dx. Here, we must somehow use these two given equalities. And since the derivatives are involved in the integral, integration by parts can be a useful tool here. As for the first integral, we let u equals g1 minus x and v prime equals f prime x, which gives u prime equals minus g prime 1 minus x and v equals fx. As for the second integral, we let u equals f1 minus x and v prime equals g prime x, which gives u prime equals minus f prime 1 minus x and v equals gx. Therefore, the first integral becomes uv, hence fx g1 minus x, minus u prime v, hence integral of minus g prime 1 minus x fx dx. Then as for the second integral, first we have minus uv, hence f1 minus x gx. Then we have plus u prime v, so integral of minus f prime 1 minus x gx dx. So we have first this part, which is f1g0 minus f0g1. And then let's write this part, which gives minus f0g1 plus f1g0. Next, the two remaining integrals can be combined into a single integral, which is the integral of this first, which is fxg'1 minus x with a plus sign, and then this gxf'1 minus x with a minus sign. Notice that this and this are the same, so we have 2 f1g0, and this are the same, so we have minus 2 f0g1. And as for this part, do you remember where you've seen this expression? Well, it is the very integral which gave us the value of minus k from statement A. So we have minus k here. Here, under the conditions f0 equals f1 and g0 equals g1, we know that this part becomes 0. So we just have minus k. So we have k equals minus k here, meaning that k equals 0. Therefore, statement B is also true. And finally, statement C, where we also have to determine whether k equals 0 or not. In the problem, this is how k is defined in the first place, as the value of this definite integral. But here, we don't actually try to calculate this integral. Instead, we are going to use this alternative expression for k, which was obtained by using integration by parts. So we use this previously obtained result. Here, unlike case B, f0 and f1 are not equal. However, if you take a look at function gx, you'll notice that both g0 and g1 are equal to 0. Therefore, this entire part becomes 0, so we only have k equals minus k, which means that k equals 0. Therefore, statement C is also true. Therefore, the answer is A, B, and C, hence choice 5. So the intention of this problem is not to find the integral of fx, but to cleverly use what you have obtained from previous statements. We didn't need to find this integral to solve this problem. And that's it, right? Wait, what is this? What's happening? Why am I hearing the boss music?